guys, we're going to hear a little bit from you about your technologies, what you're doing, where is AI shaping your companies and what you do. So Hanno, we'll start with you. Tell us a little bit about Unleash Live and what the role of AI is for your company.
Thanks, Jill. So I think we just heard that good data is actually a huge challenge for where we are now with carbon reduction. Look, most of the baseline is actually based on old data. We actually don't know how much carbon we are producing right now. And when you think about reaching these carbon reduction targets, how do we ever gonna know that we will be successful? So AI will play a fantastic role in not only collating more data, but actually analyzing it and then bringing that to real-time decisions. And that's where the connection to industrial automation is so critical, because at the end of the day, you have to have better data to actually have an effect in the physical world to reduce carbon. And what do we do in response? To get better data, we deploy sensors. And Siemens, amongst many others, are great sensor companies. You have temperature sensors, you have humidity sensors, and all of those sensors collect data. Now, surprisingly, or not surprisingly, 99.9% of the data to actually understand carbon is still collected manually. So you have students going around with clipboards, you have apps with checklists, you have things where humans actually try to understand the impact of the physical world on carbon production. We at Unleash Live, we believe that there's a better way, and that vision as a sensor is extremely powerful. It's the most powerful sense. When you think about vision, your eyes are connected straight into your brain. It's the only sensor that is connected straight into your brain. Your hand, your touch, all goes through your nervous system. So there's a delay, and it actually has consequences, because if you put your hand on a stove top, you actually burn yourself, because the decision is too late to react. But with vision, a whole new opportunity opens up. So I almost equate this to when the Voyager spacecraft started in 1977 and explored space for us. It sent data back, and the world thought this is pretty amazing. But then fast forward, we sent out the Hubble telescope, then we sent out James Webb, and just through the vision that these spacecrafts produced, we saw something amazing around us. And I think this is where we are now, through computerized vision connected to artificial intelligence. You will actually discover a baseline that is extremely important to make the right decisions to accelerate us on the carbon reduction targets. And remember, we only have 6 years, and we need to be fact-driven, very precise and iterative, working on data to make the right decisions on the carbon reduction.
I think that came across yesterday as well. We can't fix what we don't understand, and so driving forward something like that. Can you talk to us a little bit about one of the projects that you've run, or an area where you are applying AI for something concrete right now?
Sure. So we are working with Siemens and others very much in the transportation sector. So the transportation sector, we heard many times now, is very much responsible for 20% of the carbon. That's an estimate again. And how do we actually now understand how to take action to reduce the carbon footprint? So there's a lot of talk about changing the mode of transport, changing behaviors, and so forth. But do we actually know exactly what is effective and how to go about it? So we take computerized vision and we look at entire transport corridors, and we turn every vehicle into a metadata object in real time. So suddenly you understand the speed, the make of the car, the type of vehicle, a ute versus a bus versus a normal passenger car. The distance between cars, the acceleration, it becomes a metadata object for me. And you can do that with any large-scale infrastructure. It doesn't need to be transportation, but suddenly you have this object in real time. And then you take this computer vision data and connect it to data analytics. And fascinating things happen, because if it's real-time data, you can actually first report much better. You know exactly in real time. I can tell you now the carbon footprint of Sydney Harbour Bridge right now. That has never been done before. So then you can extend that to a corridor and say North Sydney versus Sydney CBD. Where is the carbon emitted right now in real time? So better reporting. Second is to actually then do scenario modeling. What if we change certain things? What if we add 50% more EVs onto the roads? But how about we just change the speed of the traffic by 5 kilometers? What effect does that have on the carbon production? And instead of just having it in a lab, you can actually see the effect in real time on the Sydney Harbour Bridge. And that's what we do. We can actually see the effect of industrial automation, so connecting it to the signage of Sydney Harbour Bridge, connecting it to the lane changes, connecting it to driver behavior, connecting it to how many buses are crossing the Harbour Bridge. We can see the effect on the carbon production on Sydney Harbour Bridge.
Are you telling us we're all part of your experiment as we cross the Harbour Bridge on
right.
Friday morning to get to work?
That's right. And if you then scale that...
Here it is Hanno, if the next time we're stuck on the bridge because he's changed design, it's all in the AI.
I will remember that.
Yeah.
Very good.
Can you automate that so you could tell my 9 o'clock meeting that I'm late because I'm stuck on the bridge?
That's exactly right. Yeah, so the scale of things is just, if you take that as, and just to give you the answer, Sydney Harbour Bridge on a daily basis emits 20 tons of carbon. The asset as Sydney Harbour Bridge, as iconic as it is, 20 tons of carbon. Now, your flight from Melbourne to Sydney was 157 kilograms of carbon. So it's great to tick the box to do carbon offsets. 57 kilograms versus 20 tons per day. And our modeling, and we actually did assessments on peak traffic and corridor assessments, solely through software and artificial intelligence decision making, we can reduce the carbon footprint of the Sydney Harbour Bridge by 20%. That's 4 tons of carbon every day, only through software. There's no behavior change. We don't need to increase the EVs from 1% to 10%. It's only AI software decision making.
Are you pushing it into other parts of the city? Or
So,
are you removing it?
So the effect is now we're getting very deep. So it's the optimal power curve of a vehicle, how fast you should optimally drive to get from A to B. So it's a corridor modeling, plus it's an optimization model, but driven by real-time data. Now, the fascinating bit is there's just so much waste everywhere, right? And we don't see it, so we need to actually bring it to life through computer vision.